All right, guys, so we've been laying down a lot of groundwork in order to get to the mesh current method. We already laid down some definitions, that of a planar circuit, that of a mesh, that of a mesh current. I drew a distinction between mesh currents that are new and the old branch currents that we had introduced in the previous chapters, and saw that there was a mathematical relationship between the two. Let's finally get to the recipe, right? Let's actually get to the steps that if you faithfully use, you can set up mesh current equations and really analyze a great variety of circuits. So this is the mesh current method. And if you like to think of it this way, a recipe. Right? Now, the first step in using this mesh current method is, first and foremost, to define mesh currents flowing along the meshes of a planar circuit. So you need to define your variables. So we're going to define mesh currents flowing in the meshes of a planar circuit. Now, I tend to like to define, once I've identified all my meshes, I like to define my mesh currents flowing in the clockwise direction. You could also define them in the counterclockwise direction. The choice is really up to you, but I tend to stay consistent, and unless I have a very good reason, my mesh currents will always be clockwise. The next is to identify the independent currents. And we're going to do this by doing one and only one thing. The mesh current accommodates voltage sources very easily, but every single time you have a current source, whether it be a dependent source or an independent source, what that does is it reduces the number of independent mesh currents by one. So we're going to identify the independent current sources by looking specifically at the current sources in our circuit. The next thing that we're going to do is we're actually going to write KVL around the meshes using Ohm's law. To express the voltages across resistors in terms of the mesh currents. Now keep in mind, these are not the branch currents. This is in terms of the mesh currents. And remember, just a friendly reminder that we have been adopting the following convention. If we go through a voltage drop, then that voltage is positive. And if we go through a voltage rise, then that voltage is negative. And furthermore, one of the things that we can do is we can actually split this up into how to add in voltages into KVL with two cases. Right? So there are two special cases here that are worth mentioning. So we have case number one, and then we have case number two. So suppose that we had the following system. So here I have a resistor. In both cases are A. And then I have, in this direction, a mesh current going this way. Actually, let me do this in a different color. Let's do this in green. So I have a mesh current going this way. And over here, I have a mesh current going in the opposite direction. Now, when it comes to our loop, there are two ways in which you can go through an element in your particular loop. You can either go in the same direction as your mesh current. So this is KVL loop, right? So this is in our loop. Or you can actually go in the opposite direction like this. So notice that in this particular case, the mesh current and the direction that we're actually going through our loop in are in the same direction, while over here the mesh current and the direction that we're going through in KVL is in opposite directions. That's the distinction between these two different cases, whether we're going in the same direction as the mesh current and adding up our voltages or in the opposite. Now, both of these, we take them into account in KVL in the following manner. Into KVL, so let's say that VA here in KVL, or let's call it, this is going to go into KVL as the mesh current times the resistance RA, and over here it's going to be minus the mesh current times RA. Now notice that one of the things that I did not do is I did not put voltage polarities on these resistors like I usually would, right? Like here and here. I did not put voltage polarities onto that. But I do know that as I start adding those into KVL, they're either going to be positive or negative depending on how we're traversing the loop compared to the direction of the mesh current. And that's the important thing. And you'll see how we use this here in a second. This is going to allow us to set up a system of equations in terms of the mesh currents. The next step is to solve the system of equations for the mesh currents. And then once we have the solution, then we're going to use the mesh currents to find the desired electrical quantity. So sometimes you might be interested in a power, you might be interested in a voltage, you might be interested in some other branch current, things like that. Then we'll use that mesh current in order to find the desired electrical quantity. So use the mesh currents to find the desired electrical quantity. And this is it. This is how the mesh current is actually going to go as we systematically go through and start solving problems. And you'll see that in the next few examples.